Alrighty, here we are on Lesson 8, Percent Error Problems. And at the top is our important definition for the day, and it talks about absolute error. And it says, given the exact value, x, of a quantity, and an approximate value, a, of a quantity, the absolute error is the absolute value of a minus x. So if you want to help you remember, x is exact, and a is approximate. Okay, so example 1 is asking us how far off. It says 3 students measured the diagonal of a screen that is said to be 15 inches. Find the absolute error for the following problems and then explain what it means. So Taylor's measurement was 15 and 2/8 inches. So this is our A. So we are going to take the absolute value of 15 and 2/8 minus the actual, which is 15, and that is 2/8, which is 1/4. B is Connor's measurement, which was 14 and 4/8, which is our A. So we're going to have 15, sorry. Oh, Right, sorry about that. Our 15 and 4/8 minus 15. So we get 4/8, which is 1/2. And last we have Jordan, which is 14 and 6/8. So we're going to have 14 and 6/8 minus 15. And again, because of that absolute value, this makes it a positive 2/8, which again is 1/4. Okay? The next part talks about percent error. And if you look at this, it's the percent the absolute error is of the exact value. So we're doing that percent, the absolute error on the top over the absolute value of the exact, then times 100. And it's pretty similar to when we use change over the original equals percent over 100. Alright, now you just have to remember to take the absolute value. So, A says find the percent error for Taylor's measurement 1. What does this mean? So Taylor's measurement was 15 and 2/8, so we're going to have the absolute value of 15 and 2/8 minus 15 over the absolute value of 15 and then times 100. So we get 1/4 over 15 times 100, which is the same thing as 0.25 over 15 times 100. And if you do all of that in the calculator, you get 1.6 repeating percent. So that is her percent error. If you flip over to the next page, it says find the percent error for Connor's measurement. So now we're going to take the absolute value of 15 and 4/8 minus 15 over the absolute value of 15 and then times 100. So I have 1/2 over 15 times 100, and when you do that in the calculator, you get 3.3 repeating percent. So that is his percent error. C is asking us to do the same thing for Jordan's measurement. So we're going to have 14 and 6/8 minus 15 and the absolute value on the top, the absolute value of 15 on the bottom, and then times 100. So you get 1/4 over 15 times 100, which will give you the same thing as the first one, 1.6 repeating percent. D says, what's the purpose of finding percent error? So the purpose is to see how close someone really is. Alright, and anything less than 10% for percent error is usually pretty good. That means it's pretty accurate. Alright, we've got 2 more examples here. It says to calculate the percent error, leave your answer in fraction form if necessary. So a realtor expected 18 people to show up for an open house, but 25 attended. So this is our actual 25, this is our X, and 18 is our A. So we're going to do the absolute value of 18 minus 25 over the absolute value of 25 times 100. So we end up with 7/25 times 100, which gives you 28%. Right, so their percent error is a little higher, so that means that their expected value was not as accurate as their actual. And one more here, it says, in science class, Mrs. Moore's students were directed to weigh a 300-gram mass on the balance scale. Tina weighed the object and reported 328 grams. So 300 is our actual, our X. 328 is our A. The word left me. The approximate. My goodness, my brain just shut off for a minute. And so we're going to have 328 minus 300 in absolute value over the absolute value of 300. And times 100. So we end up with 28 over 300, then times 100, which gives you 9.3 repeating percent. Alright, so that's all we're going to do. I think the hardest part is just deciding what's your actual and what is your approximate. But if you have any questions, we will go over those in class tomorrow.